All right, welcome to Maths with El Profe Lo, doing some elementary number theory here using textbook by James K. Strayer as a reference. Looking at the fundamental theorem of arithmetic, all right, we have Euclid's lemma that says that if A, B, and P are integers, where P is prime, then if P divides A times B, then P divides A or P divides B, okay? And then we can get into our fundamental theorem of arithmetic, which says that every integer greater than 1 can be expressed in this form, P sub 1 raised to the A sub 1 times P sub 2 raised to the A sub 2, right? A whole bunch of products, P sub n raised to the A sub n, where P sub 1, P sub 2, P sub n are distinct prime numbers, and A sub 1, A sub 2, A sub n are positive integers, right? This form, right, this product is said to be the prime factorization of the integer, okay? Now, this prime factorization is unique, except for the arrangement of the particular prime factors, and that's because of the commutative property of multiplication, okay? Now, where do we use this, okay? Well, one place is based on this definition where we say that let A and B be positive integers. The least common multiple of A and B, denoted with these brackets A comma B, is the least positive integer M such that A divides M and B divides M, okay? It is possible to use this prime factorization that we talked about up here, right, to find both the greatest common divisor, done with parentheses here, and the least common multiple, right, notation with the brackets, right? So once again, just a recollection, this is for our greatest common divisor, and this is for our least common multiple, right? Not 1 centimeter. This is the least common multiple. Be careful when transcribing. All right, so let's look at the example. Okay, so find the greatest common divisor of 756 and 2205 by using prime factorization. All right, 756 is given by 2 squared times 3 cubed times 7 to the first. 2205 is given by 3 squared times 5 to the first times 7 squared. Right? If you're not sure how to get that, we can use technology and we can say, hey, what's the prime factorization, right, of, right? And so we have the idea with 36, but we want it to be of 756. And we see 2 squared, 3 cubed, right, and then times 7. I like to put to the first power so that it's easy to distinguish. And if we want the prime factorization of 2205, Wolfram alpha will come up and give us our solution, 3 squared, 5 to the first power, 7 squared, and there we have it, okay? Now, how does this work? What we have to do is now compare the exponents on like prime numbers and choose the minimum exponent appearing in each comparison. So notice that both of these have a factor of 3 and both have a factor of 7, but we want the minimum exponent, so I'm going to use 3 squared and I'm going to use 7 to the first, right? So that greatest common divisor is going to be that 3 squared times 7 to the first, which is 63, right? And of course, we could use Wolfram alpha to double check that and say the greatest common divisor of 756 and 2205. And here it gives us that it is, right, it does give us that it is 63. And notice that when we do that, it provides us with our prime factorization, which is a useful piece of information for writing these things out. But you need to be familiar with what this process is. Okay, now if we want to find the least common multiple, all right, so once again, here is the greatest common divisor. There is the least common multiple, right? Notice that with the L like this helps distinguish it from what it looks like here, right? That this is less likely to be confused, even though, right, someone might read that and not see it as least common multiple. So just be careful. So once again, for least common multiple, we use the prime factorization. We have 756, we have 2205. We're going to rewrite these so that we include all of the prime factors that are present in the two numbers. So notice that 756 includes a prime factor of 2. Right? So I'm going to put 2205, 2 to the 0. And 2205 includes a prime factor of 5. So in 756, I'm going to include 5 to the 0. Okay? Now, why do I do that? Because now I'm going to compare the exponents, but I'm going to compare the exponents on like prime numbers and choose the maximum exponent appearing in each comparison. Right? So 2 squared compared to 2 to the 0, that's the biggest. 3 cubed compared to 3 squared, that's the biggest. 5 to the 0 power times 5 to the first, that's the biggest. 7 to the first times 7 squared, that's the biggest. And so now the product of those will be my least common multiple, right? And we see that that's going to be 26,000, right, 460. You can put the comma in there if you wish. And we can use Wolfram Alpha to check our information and say, hey, least common multiple of 756 and 2205. Right? We set that up, and so we see how that sets. And it is very, very important, right? Because if we can just do this on the computer, what purpose is there to even know how to do this? Right? And we say, hey, when you show your work, want to see this specific step. Hey, do you understand what you're supposed to select? Do you understand what you're supposed to select? Right? The minimum exponent whenever I have the greatest common divisor, and the maximum exponent whenever I have the least common multiple. Okay. In the next video, we'll work through a couple of practice problems, and it might be several practice problems to ensure our understanding. Okay, so thank you for being with us. Maths with El Profe Lo.